All right, this is Math 209, Week 5. We're finding the inverse functions. All right, this stuff is pretty easy, it's pretty fun. Basically, what you're going to do to find the inverse function. So you take your original function, which in this case is f of x equals 3x, and you replace the f of x with the letter y. All right, because really, f of x and y are synonymous. They mean the same thing. All right. Now, to find the inverse function, what we're going to do is you swap out the y with the x. You just reverse them. And so this becomes x equals 3y. See what I did? I swapped it. Wherever I saw the y, I replaced it with the x. Wherever I saw the x, replaced it with a y. That's the inverse. That's how you get the inverse, is you reverse the function, you reverse the variables. Now that we've got this, we solve for y. And so solving for y, we want to get y all by itself, which means we're going to divide both sides by 3. And so the 3's undo each other, so that gives us y is equal to x over 3. And a simpler way, or another way to say that, is 1/3 x. So our inverse function is y is equal to 1/3 x. Or you could have put y is equal to x over 3. And either one of these is what you're going to put in that box right there. All right, so finding the inverse function, again, we're going to begin with the original function, which is f of x is equal to x plus 1. We're going to replace the f of x with y. And now we are going to reverse the variables. And so that gives us x is equal to y plus 1. And now we're going to solve for y. We want to get y all by itself. So in this case, we're going to subtract 1 from both sides. The plus 1 minus 1 kind of undo each other. So that gives us y is equal to x minus 1. And we are now done. So you're going to take that x minus 1 and put it right there for your answer. All right, so we are told that this is a one-to-one function. And basically, I don't want you to worry about this, but what that's saying is it says we have a graph, and that graph is going to look like something. And basically what it's saying is when you do a horizontal line check, that you just draw any arbitrary horizontal line, that line that you draw, the red line, will only cross the blue line once. And that's basically what a one-to-one function means in this case. So anyway, to find the inverse, we are going to start with this original function, which is f of x is equal to 2x plus 8. We're going to replace the f of x with the letter y. So you get 2x, y equals 2x plus 8. And now we're just going to swap the variables. And when we swap the variables, you get x is equal to 2y plus 8. And now we just need to solve to get y all by itself. So we're going to begin by subtracting both sides by 8. The 8's undo each other, so you get 2y is equal to x minus 8. And we still want to get that y all by itself, so we're going to divide both sides by 2. And when we do that, we get y is equal to, now this means we're going to divide each term by 2. So this becomes x over 2 minus 4, because I did x divided by 2, and then I did 8 divided by 2. And if we wanted to, we could rewrite this as 1/2 x minus 4 is equal to y. And either of these will work. And it's this portion right here that you're going to enter into your answer for my math lab. All right, more of the same. It's just looking a little complicated, but it's not really. It's just the exact same process. So we're going to begin with the original function, which is this. We're going to replace the f of x with the letter y. So that gives us this. And now you're going to just switch your variables. So this ends up being x equals negative 1/9 y plus 1. And now we're going to go through the process of algebra to solve for y. We want to get that y all by itself. So we're going to start by subtracting both sides by 1. That gives us x minus 1 is equal to negative 1/9 y, because these guys undo each other. And now I'm going to multiply both sides. Now here's the thing. I want to get rid of this coefficient right here. And so the way I'm going to do that is I'm going to multiply both sides by negative 9 over 1. So I'm going to multiply both sides by negative 9 over 1. Now, the reason I was really deliberate and strategic about that is this 9 cancels with this 9, this 1 kind of like cancels with this 1, and a negative times a negative makes it a positive. So basically, it ends up being y. All right, so that's why I was very deliberate about multiplying by negative 9 over 1. Now, when I'm multiplying this side by negative 9 over 1, I have to remember I have to multiply both the x and the negative 1 by negative 9. And remember, think of this as negative 9. So when I use the distributive property here, that's going to give me negative 9x plus 9. And that is our answer. And remember, you're just going to enter in this portion into MyMathLab. All right, finding the inverse of this guy is really just the same. So I'm going to kind of make it go a little bit quicker by just starting with replacing that f of x with the letter y. So then we've got x plus 4 over 2. And now we're going to swap the y and the x. So that gives us x equals y plus 4 over 2. And now we're going to multiply both sides by 2. So that gives us 2x equals, and then this 2 and this 2 kind of undo each other. So I end up with y plus 4. And then we're still trying to get that y all by itself. So I'm going to subtract both sides by 4. So the plus 4 and the minus 4 kind of undo each other. So you get y is equal to 2x minus 4. And there is what you're going to put into MyMathLab. All right, so we are going to start by writing the original equation, although the original function, although I'm immediately replacing the f of x with the letter y. And now we're going to swap the variables. And so that ends up giving us x is equal to the third root of 11y. All right, now, so in order to get rid of this radical expression here, the third root, it means we're going to raise both sides to the third power. And that's because I want you to think of the third root and raised to the third power as the opposites of each other. And so this radical expression and this exponent kind of like undo each other. And so you end up with 11y is equal to x cubed. And now we want that y to be all by itself. So we're going to divide both sides by 11. And you end up with x cubed over 11 is equal to y. And there's your answer. Now, another way you could have written this left side is you could have written it as 1/11 x cubed is equal to y. So either of these technically would be correct. I think if I was a betting man, MyMathLab, well, I think MyMathLab would take both of them. But this way is probably the more common way that mathematicians would write the answer, and that's what you would go into that box. All right, so we're going to start with the original equation. So you get y is equal to x cubed minus 8. And we're going to immediately swap the two variables. So you end up with x is equal to y cubed minus 8. And we want to get that y all by itself. So we're going to begin by adding 8 to both sides. So that gives us x plus 8 is equal to y cubed. And we want to get rid of that exponent. since it's to the third power, that means we are going to raise, well, we're going to do the cubed root of both sides. So I'm going to kind of be explicit about that. It's the cubed root of this side and the cubed root of this side. So I did the cubed root to both sides. And so this cubed root and the exponent 3 undo each other. So that gives us y is equal to the cubed root of x plus 8. And there's nothing you can do. Nothing you could do on this left side to simplify it any further. So you are done. All right, so here we have tables, which means we don't actually have to do any math. It's really kind of nice. So let's zoom in and do this first part, which is if this is your table identifying f of x, which table represents the inverse? All right, and so the inverse, it means the x and the y are being swapped. And so if right here you have x being 1 and f of x being 5, we need to find the reverse. So we need to find x being 5 and f of x being 1, and that makes it a. So the answer right here is a. Now we can confirm right here the 9 and the 3 are swapped, the 13 and the 5 are being swapped. So the answer in this case is a. So now that we've done that, we have the inverse, and we know that that's the inverse. Now what they're asking us is to identify the domain and the range of both the original function and the inverse function. So remember, so let's take a look at the domain and range of the original function right here. Okay, and so remember that the domain is all the values that x is allowed to be, and the range is all the values that y is allowed to be. And so when we look at that, the domain of the original function is 1, 3, and 5. So what you're going to write down in your little box right here is you're going to write 1, 3, 5, and that's all you're going to put. The range for the original function is 5, 9, and 13. So you're going to put down here 5, 9, and 13, and you'll notice I put it right here already for you, so that's what it's going to look like. And then for the domain and range of the inverse function, it's the exact same process. The domain is all the x values, the range is all the y values. So when we look at our inverse function, the domain, 5, 9, and 13, and then the range is going to be 1, 3, and 5. So 5, 9, and 13 is right here, 5, 9, 13, and then the range is going to be, oops, I wrote in the wrong spot, stinker. So this 5, 9, and 13 is the domain, and then the range right here is, what was it, 1, 3, and 5. 1, 3, and 5. All right, so this is a whole bunch of words that sound really fancy, but it's really crazy simple. So the graph of this one-to-one function is given right here. So that's the blue thing right here. It says draw the graph of the inverse function, and it says for convenience and as a hint, the graph of y is equal to x has been given. That's the black one right here. That's not really necessary. So basically what you're going to do is you're going to take a look at your blue points that are already graphed. That's the original function. And so that's -4, -4. That's -2, 1, and 3, 4. All right, so there's our original function. The inverse function means you just reverse the letter, the numbers. All right, you just reverse them. And so each of these are going to become something new. So what is that? Well, this one still stays -4, -4, because the numbers were identical. But this guy right here, this becomes 1, -2, and this becomes 4, 3. So there you go. And then we're going to graph those. So we're going to go over here, and we're going to graph them. So 4, -4 goes right here. It's right there, original. And then 1, negative 2 is going to go right here. And then 4, comma 3 is going to go 1, 2, 3, 4, 1, 2, 3 right here. And there is your inverse function. So basically what you should see is it's like a mirror. It looks symmetrical, only on the other side of that line. All right, so here it says use the graph of the original function, the f of x, to sketch the inverse function. So basically what we need to do is we need to look at our graph here and get a couple of points. So we're going to zoom in really big, and we need to identify a couple of points. And I see, oh, here's a point right here. That looks like a point. I don't know if you saw right there. That looks like a point. And if I had to guess, let me see, what does that look like? Well, that looks like it's the point 0, comma, I don't know, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that's 0, 0, comma, negative 8. And then I see this point right here. Well, that's pretty easy. That's 2, comma, 0. And if I wanted to find a third point, I don't know, this point, let's see, right here, looks like it's the point 1, 2, 3, 4, 1, negative 4. So if I had to guess, this point right there looks like it's 1, negative 4. All right, so those are our original points. And so if we're going to have a graph of the inverse, we're just going to take those and we're going to swap the numbers. So this becomes 0, 2, this becomes negative 4, 1, and this becomes negative 8, 0. And so yeah, we're going to plot those points on this same graph. So 0, 2 is right here. Negative 4, 1 is right here. And then negative 8, 0. Oh, gee whiz. 1, 2, 3, 4, 5, 6, 7, 8 is right here. 12, 11, 10, 9, 8, right there. And so there is our, if I were to draw this straight line, that is your inverse function right there. So we need to identify, well, which graph looks like that? And you see that, oh, that's C. It's right here. So the answer is C. And that wraps up this video.